Alright, here is our examples of lens diagrams. You have the worksheet here. Again, we're going to draw all the stuff. It says the first, number 1 and 6 are done for you. So this is the first one for convex, and this is the first one for concave. You'll notice, just like with the mirrors, we draw one that comes in parallel and one that goes in through the focal point. And when it goes through the focal point, it refracts out parallel, and when it comes in parallel, it goes out through the focal point on the opposite side. And so we draw our image here. Now, these are actual real light rays, so it is a real image. This one's pointing in opposite direction from this one, so it is an inverted. It's obvious that the image is smaller than the object, and the image is located between C and F on the opposite side. So let's look at the next one. If I have my object is at C, so I'm going to draw my object at C, then I'm going to do one parallel, and just like with the mirror ones, it's not necessarily going to be perfect because I'm not taking perfect measurements and everything, but it's in parallel and out through the focal point. Okay, and then I'm going to go in through the focal point, and then out parallel. Oh, this one got off a little bit, so we'll redraw it. So they cross right about here. Again, it got off a little bit, but you know that they're the actual rays are crossing, so it is real, and it is inverted because they're pointing in opposite directions. If we had done our measurements correctly, you would see that it is the same size. And just like with the mirrors, it should be sitting at C. So those are the 4 things that we need to have: real or inverted, or real or virtual, inverted or upright, smaller or larger, same size, and at C. So there we go. Okay, now let's do the next one. A convex between C and F. So I draw my image, or my object I mean, and we go in parallel, and we go in through the focal point, and then we're going to go out through the focal point, and we're going to go out parallel, and so if we extend our principal axis over, there's my image. Okay, it is still a real image, and it is still inverted. Alright, this time it is larger, and its location is beyond C. Okay, I'm going to stop writing this stuff for each one of them. I'm just going to show you how to do the ray diagrams. You can figure out the rest of them. If we're at the focal point, then I go in parallel and out through the focal point. Just like with the mirrors that we did earlier, I can't go from the tip here through the focal point and then hit the lens. It's never going to hit the lens because light can't bend. So the refracted rays never cross, so this has no image. This would be a blurriness if you're looking through a lens, like when you look through a magnifying glass and you see everything gets really blurry. That would be when your object is at the focal point. So inside F, we're going to draw our object. We're going to draw it kind of small so it fits with the mirror. Alright, let me move this up a little bit. I'm going to draw it again in parallel and out through the focal point. Okay. Now this time I can't go from here through the focal point and then to the lens, so I'm going to draw it from the tip, but I'm going to draw it as if it's coming from the focal point. So it's going to go up like this. Okay. When it does that, it is going to refract out parallel. Now this refracted ray and that refracted ray don't cross, so I'm going to extrapolate them backwards. Alright, and then extrapolate this one backwards. Alright, so I got my dotted lines there, and they cross right here. So, obviously, they cross, these are virtual, so you can tell me whether it is real or virtual, upright or inverted, larger, smaller, same size, and where it's located. In this case, it is located on the same side. You'd say it's on the same side of the lens as the object. Okay? Alright. Now we get to go to concave lenses. This is where they're a little different. With concave lenses, since it's a diverging lens, we're not going to always go, we're not going to go through the focal point. What we're going to do is you draw one ray that's in parallel, and it's going to refract out as if it's coming from the focal point. And the second ray, we're going to draw it straight through the middle. Okay? So, let's do that for one that's at C. If I have an object at C, then we're going to draw one that goes in parallel, alright, and it's going to refract as if it's coming from the focal point. Okay? And then we're going to draw one that is straight through the middle of the lens. Not through the focal point or the center of curvature, just go straight through the middle. Because if light goes straight through the very center of a lens, it doesn't get refracted at all. All because of the geometry and everything. Now, this line and this line will never cross, but this one does cross right here. Just like it did on the other end. Okay, so there's my image. Now since this is not a real ray, it is a virtual image, because that's not a real line right here, this dotted one. Okay, so between C and F, my object is between C and F, like this. Then in parallel, and we go out as if it's coming from the focus, and then we have one that goes in straight through the middle. And again, your image is formed right there. So you kind of see a pattern here, right? So you can do that for all of them. So let's go ahead and do the at F. If it's at F, on all the other ones, if it was at F, we couldn't do anything. But this one, since I'm going to go in parallel and then out as if it's coming from the focal point, and then I have one that goes straight through the middle like that. Well, this time they do cross, so I do have an image there. Okay. Inside of F, I go in parallel, and then it's going to refract out as if it's coming from the focal point, even though I'm inside the focal point there, and then straight through the middle. And your image is formed right there. And there you go. So I trust that you can fill in these 4 things for each one of these different types of ray diagrams, but that is how you do the ray diagrams for lenses instead of mirrors.